I'm going to talk to you today about APIs in a peer-to-peer environment. I will be talking about why it's interesting to consider even going peer-to-peer or building peer-to-peer environments, how we can do it now, what technologies are that are available today, what the challenges are, and of course what the possibilities are and what we can do now and maybe in the future. So first, something about me. Jasper already told a lot, but my name is Marko. I'm a front-end developer at the Voorhoede. But like Jasper said, I love everything. I love full stack. I also worked as a full stack developer. I love DevOps, cybersecurity, and everything with networks. I also do have a social life, by the way. And yeah, you're all invited. I think that the internet is the mother of all change. And I think we should fight to keep the internet open and that we should keep sharing knowledge with each other, just like at this meetup today. So yeah, why should we even consider peer-to-peer or peer-to-peer environments, APIs in the peer-to-peer environments? There's some properties of peer-to-peer environments that I want to talk to you about. First of all, resilience. Resilience in peer-to-peer environments. In the internet today, we have mostly environments that are centralized. So we have big central servers that serve people content. And for example, if this node here drops and fails, then all the peers connected to the server won't get served any content anymore. And they won't have any connection anymore. A little bit better solution is to go for a decentralized environment. This means that we have several nodes that serve users or peers. So if one node drops, then only a subsection of the complete network is affected. But of course, the best thing to do is to have a distributed environment where every peer is a server and a client. And so if one peer drops, then every peer can connect to another peer and still get their content and still get the thing they're looking for. Another thing is censorship. So we all know stories, or we all know examples of governments shutting down certain websites, or even shutting down the complete internet. And in a peer-to-peer environment, this is way harder to do because content gets distributed and peers can connect to other peers, and in this way still can get access to the content. I have a really cool example of this in real life at the end of the talk. And I will show it to you guys later on. So another thing that's important is, of course, privacy. In a peer-to-peer environment, peers, they can decide what content they share. Of course, when you share content, people can download it and it can still end up in the wrong hands or in hands that you didn't want it to end up in the first place. But still, peers can delete the content that they hosted. They can decide when they do that. So we don't have to trust any third parties anymore. For example, if you upload a picture to Facebook now, then it's uploaded to Facebook and you delete it. But is it really deleted? What is Facebook doing with it when it's deleted? You can't actually know for sure what's going on. And in a peer-to-peer environment, that's a little bit more in your own hands. Another property is that we have preservation of content. So like I said before, in the current situation, we have a centralized server that's serving content. And if the server goes down, or if like the data center where the server is at burns down to the ground, which almost never happens, but it could, then all this content is destroyed and people can reach the content. In a peer-to-peer environment, because peers share content and they distribute it, if one laptop or server would burn down or crash, then it's still reachable by other peers. And a cool thing, especially in IPFS and in the DATACHANNEL protocol, which I will tell more about later, content is not addressed by location. So in the situation that we have today, content is addressed by location. So if I want to, for example, go to the Voorhoede website that's hosted on a server, and I say, okay, Voorhoede.nl, the DNS server resolves it, and we know where to fetch the content. But in a peer-to-peer environment, especially in IPFS, content is addressed by the content itself. So a hash is created of the content, and this content can be reached by requesting the content and not by requesting a specific location. I will go, maybe it's not clear what I'm talking about right now, but I will go into IPFS a little bit more. I hope that you all will understand why it's so cool. And of course, yeah, peer-to-peer, it's freaking cool. It's new. It's like we all know about Bitcoins, I think, and about the blockchain. So it's this new distributed thing. But the thing is, those apps are not done, in my opinion. Something like Bitcoin is really cool, and it's a buzz. People are investing money in it. People are making a lot of money with it, but it's not done. I think, for example, the Bitcoins won't exist in maybe 5 or 10 years. But we will get a new product that is better and has a better architecture, has better features than it has now. In a peer-to-peer environment, we're also able to share resources. So for example, like I said before with IPFS, we're able to share content. So we're able to distribute the use of storage. We're able to share bandwidth, the computing power, you can name it. It's also a new paradigm. It's always cool because we can learn new stuff, develop new best practices, and yeah, just work with new technology and new things. And we can real-time everything. So we can make everything real-time. Yeah, I think that's a really cool feature. How are we going to do that? What are the technologies that are available today with which you can work in a peer-to-peer environment? One of the existing technologies are distributed app platforms. So platforms like Ethereum, IOTA, Neo, you name it. These platforms are blockchain-based, which means they have like this distributed central state that keeps track of the whole system and keeps control that everything is like correct and not corrupted. They offer a lot of possibilities. We can distribute content again, share computing power, and so forth. So it offers us a lot of power, a lot of possibilities. But in my humble opinion, by the way, I think blockchain-based technologies like Ethereum, IOTA, and so forth are too complex for many use cases, especially for simpler apps and for yeah, it's too complicated. Also, it has a steep learning curve, which means like if you want to develop apps for Ethereum, or if you want to get started with the blockchain, there's a lot of complicated math going on. There's new concepts that we're not used to, so it's hard to get started and hard to enter this world. And I don't think that should be like this. So I would like to focus on other things like IPFS and the DAPP protocol. These two protocols are peer-to-peer file sharing systems or protocols. They allow users to share content and distribute it over several peers. They use content addressing, which means that, for example, if I have a file and I want to share it, then I don't put it on a central server and say it's located at voorhoede.nl/mygreatfile.html or something like that, but it's addressed by the content and the hash of the content. So if I have a file, hash is created of this file, which is of course unique or should be unique, and the system helps us to detect these files. So we're not saying I want a file from that location. We're saying I want this file and help me find it. Find it at any pair that has this content. And we have great tools like the Beaker browser. I don't know if anybody used the Beaker browser. I'm going to give a little demo in a second, and you can see everything about the Beaker browser. And yeah, we can fork and clone content ourselves. So if we see a website that's really cool, and we say like, oh man, I want to host this myself. I don't ever want this content to be lost. We can fork it and clone it. Just a little demo. I hope this goes as planned. So yeah, you have a Beaker browser, and I can say that I want to create a new website. So let's say the title is my first B2B site. I can add a file. Of course, I already created a little file. I import this file, I publish it, and then it's hosted and it's addressed. I don't know if you guys can see it over here. It's addressed by its content, so the hash of its content. So anybody who has Beaker installed on their laptop can enter this hash, or can share this with someone, and they can enter it. They can reach it. And what's also cool about it is they can also fork it, so they can host it themselves. Like up here, you see there's 0 pairs hosting my site. So if anybody wants to host it, please do. Yeah, and of course, for us as front-end developers, we finally got peer-to-peer to the browser. Well, not finally, it's been around for a couple of years. But we have WebRTC in the browser, which offers us peer-to-peer in the browser, which is really cool. All communications over WebRTC is encrypted. We can stream video, audio, and data over WebRTC. And the cool thing is that we can stream data. I know everybody is, when they think about WebRTC, thinks about video and audio. But in my opinion, the cool thing is that we can share data, and that's a really powerful tool. I'll talk about that later. And also a cool feature about WebRTC that not a lot of people know is that they can communicate with any system that offers a WebRTC gateway. So it's possible to make a phone call from your browser to a real phone on a desk with somebody and have a real conversation from your browser with somebody on a phone. There's a lot more peer-to-peer tools. So the creators of IPFS, they have this library called libp2p. It's like a Swiss Army knife for peer-to-peer. So if you want to develop a peer-to-peer app or a peer-to-peer API, you should definitely check out libp2p. Sorry, libp2p. It offers a lot of cool tools to set up your own peer-to-peer system. And to connect to users and so forth. And on the right side, maybe not that clear, but it's a WebTorrent. It allows you to share torrents from your browser, just like we were used to share legal movies, of course, guys, and legal audio. We can do that in the browser too. I have a really cool demo, but I'm not sure if it's going to work. So is anybody connected to the Who's connected through the Wi-Fi?
We need to do something?
Yeah, just a second.
Does it work on iPhone?
Nothing works on iPhone. So, yeah, Jasper, are you going to do it?
I'm not connected.
Oh, you're not connected.
I am connected.
Sorry? Are you connected to the Wi-Fi? Can you go to my IP address?
This IP address is filling your phone.
Yeah, that would be also great, Declan, if you did. So if you go to 192.168.2.78 and port 3000, then
Save that?
Yeah.
3000.
Then we have this really cool.
Could not get WebRTC.
Zie jezelf.
Not get WebRTC. Yeah, that doesn't matter.
Is anybody connected to
You
this?
can do it. Just.
No? Oh, great. A demo that doesn't work
Yes,
as planned.
Yeah, it's still. Oh, you were the first one. Oh, he's drawing something.
So if anybody's up here and it works. So yeah, for example, a cool thing about this is that I can drag this image, put it in here, and then if anybody was connected to me, unfortunately not, you would see the image too. And this image is also hosted or seeded on via WebTorrent. So other users, if I would get the hash of this image, I could share it with other users. Other users could connect and download the image in their browsers, and automatically they would.
Can you say it again? Because I didn't understand how you do it. Sorry to interrupt.
How did I do what?
How do you host it?
How you end up like in this situation? Are you using the browser?
Yeah, you can import WebTorrent And there's like this really simple API that allows you to host images. So I didn't write this up myself, by the way, but if I drag and drop it in here, it gets uploaded to the WebTorrent environment. And you can find this, if I share the hash with you, you can find this image, and if you download it, then automatically, like in normal torrents, you're a host yourself too, and it gets distributed over the network. Okay, it was not the best demo, sorry for that. It really worked yesterday. So yeah, of course, with new technologies come challenges. One of the most obvious challenges that we have in the peer-to-peer environment is that we don't have the client-server model anymore. So we're used to a central server serving us content, and we're the client, and we're connected to the server. But this model, because everybody is a server and a client in the peer-to-peer model, we don't have this concept anymore. So you as a user could become an API, or you could host content, and you could you could share an API or endpoints that the user could connect to. This of course means that we need to reconsider the way that we architecture our APIs and how we build it. So the API is not a centralized gateway anymore, resources or knowledge or anything, but it's distributed among pairs. So requested data normally now, if we connect to a API of Google, they have like this big data center behind it, and we connect to it, and they serve us content. But in a peer-to-peer environment, this all happens between pairs. And the cool thing is also that the data can also be real time. So it's like the whiteboard that we had before, if it works, then it will be real-time content that was shared between pairs. One of the biggest challenges actually when considering this architecture is the fact that we can't really provide a quality guarantee. So for example, if you develop an API now, what you would do is have multiple instances of it running. You would have auto-scaling groups so that you would provide the best possible quality guarantees for your users. In a peer-to-peer environment, that's a lot harder because pairs can come and go as they like. So it is difficult to satisfy this quality guarantee, and that's something that we should consider when developing APIs. And another important thing is the cooperation between the different peers that are in the network. So, for example, the app that I showed you before, the whiteboard, it uses a system that like connects every pair to every other pair. We call this a full mesh network. It sounds cool, but it's actually not, because it means that every pair is connected to every other pair, and we start dividing bandwidth. So if a lot of pairs connect, then we of course lose quality of connection, and things will go slower. I think the max now is 50 pairs, I think, for WebRTC connections, and then things really start to go bad. But in practice, most of the times, I don't know if anybody of you use WebRTC like conferencing tools. Like if you connect with 4 or 5 people, it already starts getting blurry and already starts going bad. So that's one really big issue that we have to think about when architecturing application APIs and peer-to-peer environments. And of course, everything that's connected to the internet should consider seriously the security issues that are involved with being connected to the internet in the first place. So one issue is, of course, if content is distributed among peers, how do we even know that we are served the content that we want? IPFS and the DATACHANNEL protocol, for example, use content hashing, which is a good feature because if I, for example, have a file and I have the hash of that file, and I just change one letter in the file, we'll get a completely different hash. So that's one way we can go about it, but it is a security issue that is present. Another issue is how we can control access to resources that we have. So how can we prevent people from accessing the content that we are sharing? Kind of like in the situation that we are in now. So how do you control the people accessing the content that you want to share with them, and not some content that you absolutely don't want to share? Because if you have like a password file somewhere stored, which is never a good idea, but let's say you have one, and how would you prevent people from accessing it? Yeah, and what I said before, it's peers can connect to each other, peers can come and go, but it's also difficult to control how if some user wanted to be malicious and wanted to bring down the whole network, how are we going to control this? So if somebody wants to like DDoS the whole peer-to-peer environment, how are we going to solve this? And of course, we don't have a centralized authority governing these communications and giving out tokens. And yeah, like now we can have an API key that's given to us by Google, but how is that going to be resolved in a peer-to-peer environment? There's not only challenges, of course, there's also a lot of great possibilities that we have when developing peer-to-peer applications or peer-to-peer APIs. But the first thing to notice, or the first thing to think about, is that we should be making choices. So we should be thinking about, is a peer-to-peer or decentralized distributed environment the way we want to go? A good analogy is with NoSQL databases. When NoSQL databases started to get popular, everybody wanted to use NoSQL databases. Everyone was like, yeah, forget MySQL, it's old, nobody wants to use that. We should all use Mongo or another NoSQL database. Me, myself, I also made that mistake. I worked on a project and we decided to use Neo4j, a graph database. What's cooler than a graph database? It's called Neo4j. Come on, it's so cool. And after 3 weeks, we were like, yeah, the coolest thing to use was actually MySQL. We should have used MySQL. That was a really stupid decision. So before starting a project, it's good to realize, do I need this technology? Is this going to help me to make a better product? Or bake a better product? So yeah, think about that first. Yeah, WebRTC. I talked about WebRTC, and I said to you guys, WebRTC is mostly known about video sharing and audio sharing. But for me, the cool thing is that WebRTC has a data channel where we can share arbitrary application data between the peers that are connected. The communication is message-based. It resembles the WebSocket API a lot. That's done deliberately, by the way, so that people are already used to the API. So we can reuse the patterns that we developed in using WebSockets, and we can implement them again when developing peer-to-peer applications with WebRTC. So, for example, we could define our own JSON format or JSON mini protocol when we build our API. And the cool thing is also that we can stream data to any peer that we want. So we don't have to be on the same website. We can also, for example, the whiteboard app. I think I talked to Jack about it. For me, it's a really cool idea if we have like 3 really great artists that work together on the whiteboard app. And for example, the whiteboard app could be displayed on Amsterdam Central Station, and 3 artists will be working from their home on the same project, and people could be seeing that real time. This all can happen with the data channel provided by WebRTC. So to show you guys a little example, for example, let's say we have this great Pokemon API. I know everybody wants a Pokemon API. So in the situation that we're on now, the centralized situation, we have a central server that serves all the content. So we do a request to API v2 Pokemon, we get request, and we get back all the Pokemon. And in a decentralized environment, using the WebRTC data channel, we could share the content. So people who really love Pokemon, like myself, could share a part of the content that is shared in that is provided by the API, and we could use the data channel to connect to different peers hosting this, and it will give us back the content that we want. And one of the most powerful things, in my opinion, is that we get to define our own messages. So we're not like bound to REST or anything. We can define our own messages. I use really simple examples. So we could, for example, make a message with a type read and the resource that we are requesting, or we could go with more of a REST or HTTP get and use a path variable just like we use now. So exactly like we use it here, we can use it over there. and we can map it. But it's a new technology, so we should develop new best practices, and we should look at what the best ways are to implement this in the browser. But it is cool that the data channel offers us this possibility and this flexibility, so we can structure our API like we want it to. This is an idea that I thought of myself. I would call it the brain fart if Jasper wasn't here, but I'm not going to do that. It's called distributable APIs, and it would be in my opinion, would be a real cool technology. I talked about it with Anne yesterday, and he said like in all of these science fiction movies, they have like a watch or something, and if they have a door and a TV, and they just go up with the watch and like to the door, and the door opens, and they go to the TV, and like this, their favorite show pops up, and he was like, but that's not possible. That's not feasible with today's technology. It's just not that easy to make all different things communicate with each other. And I think if we have distributable APIs, so APIs that can be reused by different pairs, we will move closer towards this goal. So what I mean is like that we have plug and play APIs, so really generic APIs that get shared amongst different pairs, and pairs can share their own content. So I have a really generic API that shares their own content, backed by their own content, or backed by the content that they already once requested and fork or host themselves now. So just like in WebTorrent, if you download something, you have the content on your machine, and you host it yourself. This is something that we could do in the future with APIs. In this way, a user becomes an API and hosts the content itself. And another cool idea would be like, somebody's talking about GraphQL. So a really cool idea would be like a distributed GraphQL, which like you fire off a query to all the pairs, and this magical system gives you back exactly the information that you want and shares all the bandwidth between all the different pairs. So maybe this is a little bit abstract, so I made this beautiful drawing. So we have Bob over here, and Bob visits an API, and he thinks, wow, damn, this API is really cool. So he forks the API. He has the data because he requested the data. So he stores the data on his own machine, and he forks the API, and he's the API himself now. So other pairs can connect to Bob now, and they can access the data from the pair, but they can also fork the API again. And they can also collect the data that Bob has, or the data that they requested, and host it themselves. So this way we have like a distributed pair amongst, distributed API amongst all the pairs that are available in the network. And another cool thing is that we can also have APIs. So for example, let's call her Lillian. Lillian also has this API, and she's like, oh, this is a really cool API. I'm going to fork this API, but I want to back it up with my own data. So she has data that the API can handle. She has it stored on her own local machine. She just forks the API, hosts it on her own node, and provides all the pairs with this interface, but backed by her own data. Another possibility is, of course, with the growth of IoT, Internet of Things, everything is becoming smart now, from keys to remote controls to fridges, you name it. So this is a new peer pool that we're addressing, and I think peer-to-peer is a perfect fit for the Internet of Things, because all these devices are around us, they're surrounding us, and it's so easy to actually connect to those devices. I have a peer-to-peer environment set up with all the devices around us. And again, I made this beautiful drawing. So let's call him Tim. Tim wakes up, and he has to catch the bus. He has to go to work. So he requests the bus times, and he looks at when the bus is leaving. He's like, oh, damn, there's a new schedule for the bus. We all have had this once, and you miss the bus, you're late for work, your boss gets really mad. And if you have a boss like Jasper, he gets really, no. So, and what happens is that Tim, he gets back the data, but because it's a whole house and all the devices in this house are connected to a peer-to-peer network, he starts sharing this content. So this content is shared to the alarm clock of his wife. Let's call it Betsy. And Betsy has this clock that is really smart and gets this information. And it's like, oh, there's a new schedule. And Betsy has to be at work at 9:30. So it updates the time that it is going to ring. And it updates it, and it gets shared, and she wakes up on the right time, and she comes to work, and the boss doesn't get mad. Of course, yeah, one side note is this is already possible now, but actually everything that I talked about is possible now, but it's more of like the architecture that's behind the peer-to-peer system makes this so efficient and so like the architecture is optimal for this. But we could also share video and also make like phone calls using a REST API, which would like the performance would suck, of course, but it is possible. So everything is actually already possible. It's just the architecture that provides us with such great power. Yeah, I want to go in a little bit more on content addressing and what implication this had. So first of all, content addressing allows us to preserve content. So if we build an API or if we have data that we have stored somewhere, content addressing allows us to share this content between pairs. So we don't have to store it in a central location or in several central locations anymore. We can share it amongst pairs. And because the content is addressed by its hash or by the content that it contains, it is always reachable. So if you have some content that you really like and you want to preserve it, you can always host it yourself, and people can still find it because it's not bound to a location, but it's bound to the content. And that's really cool. Yeah, since hashes are unique, we can always retrieve exactly that file and not the other one. Because if people start making changes, let's say, for example, we have a data set that's really cool, and we want to share this, and people start hosting this, but they start changing things to it in this data set just to corrupt it or to mess with us, then we know it's not that content because the hash won't be the same, and we won't find that content at that pair, so we won't get corrupted content. Yeah. Yeah, and of course, yeah, your API is not bound anymore to a single service, so people can share it, people can back it up with their own data, people can back it up with your data that they host themselves. So in this way, we share bandwidth, we share, and we keep the API alive, so it's always reachable. Yeah, just for you guys to understand it a little bit better, I think it's good to give a little demo, which hopefully will go good enough. So I made this directory. It contains hello HTML. So what I'm going to do is I'm going to first I would initialize this direction. So I'm using IPFS now, by the way. I really suggest that you read on IPFS. It's really cool. Oh yeah, sorry. Thanks. Yeah, so I go into the directory, and what I would do, I installed IPFS on my machine. I would initialize the directory just like you would do with Git, for example. You would do git init, and would initialize a Git project in the directory that you're in. Already did this, so I'm going to skip this step. After, I would add the hello.html. And what this would do is it would create a hash of the content in the file. And with this hash, I can now get back the contents of my file. And anybody hosting this content or anybody wanting this content could find this content by the hash that it has. So if I go to this is also a cool thing. So if I use this hash in the browser and go here. I'm gonna message saying hello API peeps, and this is the file that I just uploaded using IPFS. This, by the way, how this works is that IPFS hosts like this proxy server that lets you connect to the peer-to-peer network of IPFS from a regular browser. So this is not really peer-to-peer, but in the background it's still served peer-to-peer.
Are you also hosting the file now?
Yeah.
After you browse to it?
Yeah, but I was already hosting it. So no, if you do it from a browser, then not. You can if you use the CLI client, then you can do host it yourself.
So you can disconnect your daemon?
If I disconnect, to be honest, I'm not really sure, because if I disconnect my daemon, then this is still reachable, but I'm not sure if this is like a feature offered by the IPFS proxy that just like caches the content, or if I'm really able to connect to it. I'm not sure about that. Sorry, guys.
It feels like it has downloaded the content to the browser web storage or something.
Yeah, but if I do a hard refresh, also I think it's something with the proxy of IPFS that they like.
Maybe try to take a look at it.
Yeah, sure.
Now really curious.
It's a type if it's
Yeah. So I think it's a caching thing done by IPFS. And of course, yeah, these names are terrible. Like you never go to a person and say like, I have this really great site. Please visit it on a capital letter Q and capital letter R, capital letter U. So they have this. It's called IPNS. It's an interplanetary naming system. I don't know why you hate the name that much. I love the name. It's the interplanetary naming system, and it allows you to bind a hash of a directory to that directory, so you can always read the same content by using that hash. And if the content gets updated, of course, gets a new hash, so you can reach it with a new hash, but also with the IPNS hash that you define. So yeah, of course, these are all like great ideas and would be perfect if it worked. But in real life, it also works. So for example, the Spanish government, we all heard about the independence of Catalonia and they didn't want to become independent. The Spanish government wasn't really glad about the idea of independent Catalonia. So what they did, the Catalonian government hosted at some websites which contained the locations of voting booths, and the Spanish government again wasn't really happy with that. So they took down all the websites hosting those voting booth locations. And what the Catalonian government did is they used IPFS to share this content between peers, so it would still be available for all the peers. And in the end, I think they got 90% vote for independence. So I think it worked. I'm not sure. They didn't get independent, but yeah. So with this, I want to thank you guys for listening to me. And if you have any questions, please ask them. Yes.
Well, this sounds really great for content that you never want to see go away. But what if you do? For copyright infringement, for instance, how do you get rid of it?
You can always the content that you share, you can always delete it. So it's on your machine, and you can delete it. And of course, if you put it online and people start forking it and sharing it, then of course it still will be reachable. But that's the same thing. Like if you upload a picture now and somebody downloads it, then they can also do anything that they want with it. So it's first of all a good idea to think about what you're hosting. If you're never sure that you want to host it forever, of course, but it's good to think about it. And it's a risk that you take, I think, when you put things online.
You got that great idea for peer-to-peer API. But how do you think about where does the single source of truth is in that?
Well, yeah, that's a really good question. A single source of truth is, for example, like IPFS does it. It's the hash that you have. So the hash is unique. So that's the truth of the content that you share. So for example, your API is just a program. It's just letters and characters, and they can also get a hash. So that's the point. That's a single point of truth, the hash actually.
Yeah.
In this system.
And also, if you have an API slash schedule.
Yeah, bus times or yeah.
Bus times, which has the truth when the bus.
Well, all the files, so also the data, but also the code of your API, they have a unique hash. So if this content has a certain hash, then that's the truth. So and that gets shared between pairs. And if I want to reach this content, then I address it by the hash, so I know it's the same content. Because if I change anything, the hash would also change, and I wouldn't get that file served.
But this is exactly my question, because now everything is versioned and everything is static.
Yeah.
So if the bus times update and I don't have the new hash, how will I know?
Yeah, but you could use, for example, in the IPFS realm, you could use IPNS. And the IPNS maps like this certain hash to like this location on a certain machine, and that gets served.
So IPNS has ownership then? Like, I mean, like there's one owner that can say like, okay, this IPNS hash points to this hash, and if you update it, then you can change the pointer. Okay.
Yeah.
And it's the same for the DATT protocol?
I know a little bit more about IPFS than that. I know that as a Pico browser, which is really cool. You can host like a website in 6 seconds. If you're really fast.
Yeah, because that's like the same question about that. Because I was like, if you host this website, then if you want to update the website,
well, I tried it out with Anand yesterday, and it kind of worked, but it still kept the same hash for the content. So I'm not sure how they do that. I think they have like this built-in mechanism that is something a little bit like IPNS.
Yeah, I have a question. If you participate in this network, you host something like an application or file storage, that costs resources. Don't you think there's a requirement for some kind of reward or incentive? Like, because that's the whole reason why Bitcoin and Ethereum work. Is there some incentive structure in place?
Yes, I think for a lot of for some applications that definitely is true. But I also think like I'm standing here, also not getting paid, sharing information with you guys, sharing knowledge. Hopefully, if there's something. So I think it has like a use case, and I think a lot of people will use it and will share the content. And also, if they use the network, like with torrents, you're kind of obliged to host it yourself. But it is really a good question. It is also like in human nature to want to get back something if you invest something. So it will definitely be a consideration when developing something. But then you could also choose for this distributed app platform, like Ethereum or Neo or something like that.
The cool thing about this is that it takes you back to the early days of the internet when people had just their personal homepages and put stuff on there that they liked, and hopefully somebody else would like it as well. The counter. Whereas the web now is like 99.9% for commercial purpose.
Yeah.
And this takes it a little bit back to hosting your own stuff, and like we discussed also, if I like boxing, so I put my boxing outcomes and schedule online, and people just share it and they say, hey, I can use this API model for my cricket.
Exactly. I think also people think it's cool to host their own content and be part of this network. So indeed, you have a point that there should be an incentive, but maybe it's not only monetary incentive, so financial incentive, but you can find different ways of driving people.
So someone who finds a way to monetize it.
Of course.
Like GitHub, right? Like how many people publish stuff at GitHub?
Yeah.
Let's give it away, right? Like millions, right?
And of course, everybody wants to. I'm not going to say it. You have to.
How do you? I get the concept of having a hash to represent the data, but how do you see this non-human readable string being used in the wild? I get the naming system, but isn't that a requirement?
Yeah.
A requirement for it to take off?
Yeah. For example, DOT has this. I read like 10 articles about this because I was thinking about the same. Like nobody's going to visit the hash. Like, so I read about this, and like the best thing that I came across was DOT uses aliases. So you can, for example, name this website Voorhoede and connect it to a hash, and then you will always visit that that website. But then again, on another computer it won't work because they have to do the alias itself. And after reading those articles, to be honest, I don't have a good solution for this. But again, we're still at the like at the start of this whole distributed thing. So I think there's a lot to learn, and there's a lot of new cool features and new technologies that are going to be developed. And I think like the naming thing is a really big issue. And I think that's something that will come with time. But for now, there's not really a
You can hyperlink stuff, right?
Sorry?
You can hyperlink stuff, right? Once you're at the Voorhoede, then you have a file.
Yeah, then you can hyperlink
it. These hashes, then you can just click the human readable names and go to the
Yeah, that's true, but still you have to go to the hash, and that's like you have to share the hash.
Personally, I would be too afraid of this because currently the internet, if IP addresses, nobody is sending IP addresses to each other. We already made something to translate non-readable strings to readable strings. So I think that's a technical problem, which might be difficult for now, but it's probably going to be solved in, what is it, 1 year or something?
Yeah, I think that's a bit how the IPFS thing works. Is like DNS.
Yeah, the name.
But then you trust some third party to have those mappings.
Yeah, that's again like against
the
distributed
blockchain. Like we're all peer-to-peer, and we're doing the peer-to-peer name server thing. Then you solve that problem. So I think that shouldn't be very difficult.
So yeah,
it's a lot of overhead to distribute the entire name server for.
But again, you can distribute parts
could.
of that to different peers because you don't have not every peer. Like one thing about Bitcoins is that everybody has to have the complete ledger, I think, to be able to do anything. But in a peer-to-peer environment, you don't have to have anything, everything. You can have like several parts of it, and people can connect to you. So we could make like a distributed DNS system that like tries to connect to all these pairs and just sees this guy and like, oh yeah, he has the hash of the name that I requested, the URL or even. But it is one of the biggest issues indeed.
I think there might be even more questions left. I know that I still have 20 in my head, but I also see that there's some food ready. So with that, I would actually like to thank you, Marko. I really enjoyed your talk. And so for the rest